Ladies and gentlemen, boys and girls, welcome to another math video. Today we're going to be talking about circles, more specifically parts of circles. All right. So we're going to be talking about arcs and sectors. So if we have our circle, all right. Please become a circle, okay, or dot. So if we have a circle, okay, fine. Don't identify it as a circle. That's cool. We're going to be talking about arcs, which is, say we have a point on our circle to a point on our circle. We have this arc right here, this portion of the circle. Let me do that in different colors. We have this part to this part. This would be considered an arc of our circle. Then we also have what are called sectors, sector of our circle. So a sector is a similar thing to an arc, but we pick a point on our circle to start and stop. And now, instead of just being the distance around the circle, like an arc, a sector is this sort of pie-shaped wedge area. We want to find this area of this wedge on this circle. Okay? Arcs and sectors. So arcs are part of the distance around a circle, and sectors are part of the area of a circle. Okay? So let's remind ourselves of a couple formulas. So for the circumference of a circle, or the distance around a circle, the circumference, the distance around a circle, is equal to 2 times pi times the radius of the circle. Okay, so whatever the radius of the circle is, we multiply that by 2 and multiply that by pi, and that'll give us the distance all the way around our circle. That gives us our circumference. Okay, so then area of a circle is the following. The area of a circle is equal to pi times whatever the radius of the circle is, and then we square that radius. Okay? So area is equal to pi times the radius of the circle. So we find the length of the radius of the circle, which is, again, our distance from the center to the side of our circle. And if we square that, multiply that by pi, we'll get the entire area of the circle. So I use the same color for circumference and area that I did for the arc and sector because they're going to be related. So this formula is for circumference, and this formula is for area. Okay, so if we want to find, let's deal with the arc length. So the arc length. If we want to find the arc length, that's going to be equal to, we're going to just take the circumference of the circle, so 2 pi times r, and we're going to multiply that by some fraction. We're going to multiply that by some fraction because we're only going part of the way around the circle. We need to figure out a way to talk about how much. So if we imagine that these endpoints are connected to the center of the circle. Okay, so these two endpoints are connected to the center of the circle. These two lines from our center of our circle, this guy and this guy, form an angle. All right, so that angle is some measurement. Let's call this a measurement m. All right, we don't know what that m is, but we do know it's m degrees. All right, so if we know that this is m degrees, we want to say, okay, what fraction of the whole circle is m? So if we take m degrees divided by the total number of degrees in a circle, which is 360, that'll give us the fraction of the circle that this arc makes. Okay, so this arc makes. So let's say we have, for arc length, I'm going to use the letter S. Right, S. All right. So for arc length, we're going to say that S equals 2 pi r times our central angle divided by 360. Okay? So this is going to be our formula for arc length. So let's say we have a circle. Okay, thanks for making it an egg. So we have a circle. There we go, it's a little better. And we have an arc that goes from here to here. All right, and this is a, let's say, a 3 centimeter radius. Let's say the radius is 3 centimeters. And the angle that these make, thanks Google. The angle that these make, we'll say, is 120 degrees. 120 degrees is the angle that these make. Okay? So let's find the arc length for this. Well, we plug all these numbers that we know into our arc length formula. So S, our arc length, equals 2 times pi times r. R is our radius. Radius is 3 centimeters, so 2 times pi times 3 times m degrees, or the angle in the middle. So that's 120 degrees over 360 degrees. So once we have that filled in, we can then take, that, plug that into our handy dandy calculator. All I have to do is find the calculator. There we go. Nailed it. All right, so I'm going to go ahead and just clear all these out, so it's not overloaded with stuff. And then we're going to plug in the numbers, the equation that we found. So 2, and then if I want pi, again, I can go down here. Let's make sure I'm in degree mode, because I'm using degrees. I want to use pi, it's down here. There's pi, 2 pi times r, which is 3. So 2 pi times 3 times 120 degrees divided by 360 degrees. And we hit the equal button. Oops. Backspace, return. There we go. So we get that our arc, that the length of our arc is 6.28 centimeters. So S equals 6.28 centimeters. Okay, so that'd be our arc. Okay. So let's use a similar idea to find the area of that sector. Okay, to find the area of this sector, this little pie piece right here. All right, so our formula for our area is very similar to the arc length. So if we take our area, that's going to be equal to pi r squared, but now that we're only finding a part of the circle, again, we need to do that same fraction thing that we did for arc length. So we're going to take m degrees divided by 360 degrees. All right, and this is our formula for area, or the area of a sector. All right, so if we want to find the area of that sector in this circle right here, we plug in the numbers that we are using in the spots that they belong. So that's pi r squared. Oops. Since we know our radius is 3, so pi times 3 squared times m, which is 120 degrees, over 360 degrees. So pi times 3 squared times our fraction, since we're only using a part of our circle, area equals a number. So again, we're going to plug in our numbers. So pi times r, which is 3, we're squaring 3, and then we multiply that by our fraction 120. 120 divided by 360. So we get that the area is 9.42. Area equals 9.42 centimeters squared. Okay, just like that is how we will calculate areas of arc, or areas of sectors, and lengths of arcs. Okay, different ways we can calculate that. With that, you'll have some practice problems. Use these equations to solve those problems, and I will talk to you guys later. Bye.